Okay, now we have the question. Find the equation of parabola in standard form. In order to obtain the equation of parabola in standard form, we take x-axis as the axis of parabola and f with the focus, rt with the directrix, and vertex at origin. Let us take a. So we can write to get the equation of parabola in standard form. We take vertex a at origin and axis of parabola as x-axis. Let f be the focus and rt be the directrix. अब हामीले यो फोकस र डाइरेक्ट्रिक्स लिँदाखेरि जहिले पनि एएफ इक्वल्स टु एजेड हुने गरी लिनुपर्छ. बाई डेफिनेसन अफ एभ्री पोइन्ट लाइङ अन द कर्भ इज अलवेज इक्विडिस्टेन्ट फ्रम फोकस and directrix. That's why let f be the focus and rt be the directrix. The directrix means axis at z. We take pxy be any point on the curve, on the parabola. In this way we can take any point pxy on the parabola. We join pf and draw pm perpendicular on directrix. Then by definition of parabola we have pf equals to pm. So here we take pxy be any point on the parabola. We join pf and draw pm perpendicular on directrix. Suppose that ZA equals to AF equals to A. Then the coordinates of F and M will be A comma 0 and minus A comma Y. This is because vertex A at origin we already know that, and here AFA and ZA equals to A. Both are of equal distance from the vertex. यो ZA equals to AF भएकोले यहाँनिर यो x एक्सिसमा पोइन्ट लाई गरेको हुनाले f को कोअर्डिनेट a, 0 भयो, and this is a point on the second quadrant. In second quadrant x is negative and y is positive. So this is minus a distance. यहाँदेखि यहाँसम्मको डिस्टेन्स हाम्रो a हो, बट x ड्यास तिर भएकोले यो x कोअर्डिनेट माइनस a भयो. अनि यो m भन्ने पोइन्ट त यो p को p सँगको डिस्टेन्स जतिकै छ, त्यसैले यो डिस्टेन्स y भएको कारणले यहाँ z देखि m सम्मको डिस्टेन्स पनि y नै हुन्छ. देयरफोर द कोअर्डिनेट्स अफ m इज minus a, y भयो. अब अब हामीले के निकाल्नु छ? वी नो दैट बाई डेफिनेसन अफ द प्याराबोला वी हैव पीएफ इक्वल्स टु पीएम। प्याराबोलाको डेफिनेसन अनुसार कर्वमा भएको कुनै पोइन्टबाट त्यसको फोकससँग लिएको डिस्टेन्स इक्वल्स टु कर्वमा भएको पोइन्टबाट त्यसको फिक्स्ड स्ट्रेट लाइन डाइरेक्ट्रिक्ससँग लिएको डिस्टेन्स जहिले पनि इक्वल हुन्छ। सो by definition of parabola we have pf equals to pm, but before writing that we have to find the equation of the directrix rt. So f and m will be a comma 0 and minus a comma y respectively. Also the equation of directrix rt is x equals to minus a, that is x plus a equals to 0. By definition of parabola we have pf equals to pm, that is our distance formula लगाइदिउँ। p देखि f सम्मको डिस्टेन्स इक्वल्स टु p देखि m सम्मको डिस्टेन्स हुन्छ। त्यसैले बाई डेफिनेसन अफ प्याराबोला वी हैव pf इक्वल्स टु pm एन्ड युजिङ डिस्टेन्स फर्मुला pf भनेको हाम्रो x माइनस a होल स्क्वायर प्लस y माइनस 0 होल स्क्वायर इक्वल्स टु रूट ओभर x plus a whole square plus y minus y whole square, squaring on both sides. We get x minus a को whole square plus y square equals to x plus a को whole square, x square minus 2ax plus a square plus y square equals to x square plus y 2ax plus a square, x square cancel भयो, a square पनि cancel भयो, or y square equals to 2ax plus 2ax, therefore y square equals to 4ax, which is the required equation of parabola in standard form. In this way we can find the equation of parabola in standard form. This is called y square equals to 4x is called the equation of parabola in standard form. A chord which passes through focus is called focal chord, and here the chord PQ is a special type of chord which is also called the Latus rectum. Okay, now we have to find the end point of the Latus rectum, the end point of the point P and Q. Point P र Q को line PQ हाम्रो Latus rectum हो. A chord which is perpendicular to the axis of parabola and passes through focus is called latus rectum. Now if the equation of parabola is y square equals to 4x, now we can find the end point of the latus rectum in this way. Equation of parabola is y square equals to 4ax. अब हामीले लेटस रेक्टमको एन्ड पोइन्ट पी र क्यू को कोअर्डिनेट फाइन्ड गर्नु छ। यसका लागि यो भर्टेक्सबाट फोकससम्मको डिस्टेन्स वी हैव x इक्वल्स टु a छ। सो व्हेन x इक्वल्स टु a, then y square equals to 4a into a, that is y square equals to 4a square, therefore y square equals to 2a को whole square, there or y square equals to 2a square, therefore y equals to plus minus 2a. Hence अब x को भ्यालु एउटा हुँदाखेरि y को भ्यालु दुईवटा आयो. That's why the latus rectum is also known as the double ordinate. So hence the end point of the latus rectum for a parabola y square equals to 4ax r a comma 2a and a comma minus 2a. In this way we can find the endpoint of the latus rectum for a parabola y square equals to 4ax as a comma 2a and a comma minus 2a. Let it be the remark 1. Now we have another remark. The parametric equations of the parabola y square equals to 4ax are x equals to at square and y equals to 2at. So any point on the parabola y square equals to 4ax can be taken as at square comma 2at, because this point also satisfies the equation of parabola. We can see this here. 2at square, the value of y is 2at, equals to 4a into at square. Therefore 4a square t square equals to 4a square t square. So this point satisfies at square comma 2at satisfies the equation of parabola. So we can take any point on the parabola as at square comma 2at. Number 2, the second case. Now if the parabola turns to the left from its vertex, a parabola left तिर turn गर्यो भने obviously its directrix will be the opposite of this direction. Suppose this, in this direction the rt is the directrix and y dash be the y-axis. This is the point z. Let it be the point, let a be the vertex and f be the focus. In this case this distance equals to this distance, and suppose that az equals to za equals to af equals to, we have supposed a in previous case also. Then the coordinate, then what will be the focus? In this case the focus will be minus a comma 0, and equation of parabola, in this case the equation of parabola, in this case the equation of parabola is y square equals to minus 4ax, where vertex of this parabola is 0 comma 0, focus of this parabola minus a comma 0, equation of is x equals to a, that is x minus a equals to 0, and length of latus rectum equals to 4a. In general the coefficient of x represents the length of latus rectum. We have the endpoint of the latus rectum pq are p a comma 2a and q a comma minus 2a. So pq equals to length of latus rectum, and by distance formula we have pq equals to 4a, that is the length of latus rectum for a parabola y square equals to 4x is 4a. So in this case also, if the equation of parabola is minus 4ax. Okay, if the parabola turns to the left from its vertex, then its equation will be y square equals to minus 4ax, where the vertex of the parabola is 0 comma 0 and focus minus a comma 0, and the equation of directrix in this case x equals to a, that is x minus a equals to 0, and the length of latus rectum equals to 4a. However, the coefficient of x is in this case minus 4a, but the length cannot be negative. That's why we take the length of latus rectum as 4a. In previous case, we have the endpoint of the latus rectum are p a comma 2a and a comma minus 2a. Therefore, pq equals to the length of latus rectum equals to, we have shown, 4a. Hence, in the parabola y square equals to 4ax, the length of latus rectum is 4a. So, in this parabola also, the equation, the length of latus rectum is 4a. Now, again, if the parabola turns upward from its vertex, then let the vertex be at origin, let it be a, and f be the focus. On axis lies on y axis, let rt be the directrix, and it meets y axis at the point z. Suppose this is y dash and this is the point f, and za equals to af equals to a. Suppose we take a. Now, in this case, if the parabola turns upward from its vertex, then its equation will be y square. The equation of parabola is x square equals to 4ay, because in this case the axis of parabola is along y axis, so equation of parabola is x square equals to 4ay, and its vertex equals to 0 comma 0. Focus, if za equals to af equals to a, then its focus will be 0 comma a, because in y axis x coordinate remains 0, so the coordinate of the focus is 0 comma a, and equation of directrix is x equals to, sorry, y equals to minus a, that is y plus a equals to 0, and length of latus rectum equals to 4a. The another case, if the parabola turns downward from its vertex, then let it be the origin, vertex a at origin, axis along y axis for this parabola, and this is the directrix. Let it be rt be the directrix in each and every case. We have supposed that, and the directrix intersect the x-axis, the y-axis perpendicularly at the point z, and this distance must be equals to this distance by definition of parabola. Suppose f be the focus, and we have taken in each and every case the distance za equals to af equals to a. Then the coordinates of the focus in this case will be 0 comma minus a, because in y-axis x coordinate is 0 and the f lies along y dash. That's why the coordinate of the focus is 0 comma minus a, and the equation of the directrix will be y equals to a. Then in this case the equation of parabola is x square equals to minus 4ay, and its vertex equals at origin 0 0. Focus, coordinate of focus equals to 0 comma minus a. Equation of directrix equation of directrix is y equals to a, that is y minus a equals to 0, and length of Latus rectum in this case is also 4a. Length of Latus rectum in this case also 4a. So these are the four cases of the parabolas. Find the equation of the parabola whose axis is parallel to x-axis and vertex at any point h comma k. Now we have to find the another equation of the parabola whose axis is parallel to x-axis and the vertex is at h comma k. Now to obtain the equation of such parabola, this is x-axis, xo x dash, and this is the line, perpendicular line, yo y dash, known as y-axis. Okay, by question the axis is parallel to x-axis. Given that the axis of the required parabola is parallel to x-axis, and we take a parabola, this, the vertex of this parabola, this is the axis of parabola, and let a be the vertex having coordinate h comma k, and suppose that f be the focus, and and we have to take this distance af, the same distance az, the distance az equals to af, because every point lying on the curve is always equidistant from focus and directrix. So we have to take za equals to af equals to some distance, let us suppose a, standard supposition that is, and rt be the directrix, which is, now here is our relation. We know that a directrix is always perpendicular to the axis of the parabola, axis of any conic sections. Okay, in previous case also, in standard case we have taken any point on the parabola, so is the case here too. So let us take the point pxy on the parabola. We join pf and draw pm perpendicular on the directrix. Now if we find the coordinate of f and m, then almost our solution will be completed. So suppose that za equals to af equals to a, and then the coordinates of f will be h plus a comma k, because the distance, the coordinates of the point a is h comma k, and the distance taken from vertex to focus is a. So this distance, this total distance up to here is h. ओरिजिनबाट एफसम्मको डिस्टेन्स एसम्म एच छ, यसमा ए थपेपछि यो एच प्लस के भयो एक्स एक्सिसतिर, वाइ एक्सिसतिरको टोटल युनिट हाम्रो यो के भएकोले प्यारलल लाइन हुँदाखेरि हाम्रो एफको कोअर्डिनेट एच प्लस ए कमा के हुन आयो. अब सिमिलरली इन अर्डर टु अब्टेन द इक्वेसन कोअर्डिनेट अफ एम, एमको कोअर्डिनेट निकाल्न यहाँदेखि यहाँसम्म कम्प्लिटली हाम्रो डिस्टेन्स एच छ, एदेखि एसम्म, यो डिस्टेन्स भनेको ए हो, दिस डिस्टेन्स इज ए. सो इफ वी सबट्र्याक्ट देन टोटल दिस डिस्टेन्स इज वी हेभ एच माइनस ए. ओरिजिनबाट यो लाइनसम्मको, दिस इज द लाइन प्यारलल टु वाइ एक्सिस विच इज एट अ डिस्टेन्स एक्स इक्वल्स टु एच माइनस ए फ्रम द ओरिजिन. सो वी क्यान टेक द कोअर्डिनेट अफ एम एज h minus a, the coordinates of m as h minus a comma y, because the distance along y axis is y. So we can write here a parabola whose axis is parallel to x-axis and vertex at any point h comma k. Let f be the focus and rt be the directrix. rt be the directrix. Directrix rt meets the axis at the point z perpendicularly. We take pxy be any point on the parabola. We join pf and draw pm perpendicular on rt. Suppose that in previous case also, suppose that अघिल्लो केसमा पनि हामीले सपोज गरेका थियौं ZA equals to AF equals to A. Then what will be the coordinates of the point F and M? Suppose that ZA equals to AF equals to A, then the coordinates of F and M be H plus A comma K and H minus A comma Y. Now by definition of parabola we have PF equals to PM. That is, this is because every point lying on the curve is always equidistant from focus and directrix. So we have PF equals to PM. That is, PF equals to root over x minus h plus a whole square, x2 minus x1 whole square plus y minus k whole square equals to over x minus h minus a whole square plus y minus y whole square. Squaring on both sides, we get x minus h plus a whole square plus y minus k whole square equals to x minus h minus a whole square. Or squaring on both sides, we get x minus h plus a whole square plus y minus k whole square equals to this whole square column, or x square minus 2x into h plus a plus h plus a whole square plus y minus k whole square equals to x square minus 2x into h minus a plus h minus a whole square, or यो x square cancel भयो, or minus 2hx minus 2ax plus h square plus 2ah plus a square plus y minus k whole square equals to minus 2hx plus 2ax plus h square minus 2ah plus a square, or हामीसँग y minus k को होल स्क्वायर इक्वल्स टु यो 2ax उता गयो, यता पनि 2x छ, 4ax भयो, अनि यो 2ah प्लस को छ, उता जाँदा माइनस भएर माइनस 4ah भयो. देयरफोर y minus k को होल स्क्वायर इक्वल्स टु 4a into x minus h, which is the required equation of parabola, which is the required equation of parabola whose axis is parallel to x-axis and vertex at any point h comma the conclusion of the theorem. यसबाट हामीले के कन्क्लुजन निकाल्न सक्छौं भने इक्वेसन अफ प्याराबोला y minus k को होल स्क्वायर इक्वल्स टु 4a into x minus h हुने बेलामा the coordinate of vertex we found, this is given to us, coordinate of vertex h comma k, coordinate of focus equals to h plus a comma k, equation of directrix origin बाट h minus a distance टाढा थियो, so it is x equals to h minus a, which is the equation of directrix in the parabola y minus k whole square equals to 4a into x minus h, and length of Latus rectum equals to 4a. Now the equation of parabola whose axis is parallel to y-axis and vertex at h comma k is x minus h whole square equals to 4a into y minus k, which can be derived as before this, whose vertex is at the point h comma k and focus is h comma k plus a. Equation of directrix is y equals to k minus a, and length of Latus rectum equals to 4a. In this way, we can find the equation of parabola whose axis is parallel to y-axis and vertex at any point h comma k. The equation is of the form x minus h whole square equals to 4a into y minus k. Remarks: 1. If y coordinate of the vertex and focus are same, then the axis of parabola will be parallel to x-axis, and similarly if x coordinate of the vertex and focus are same, then the axis of parabola is parabola will be parallel to y-axis. Number two, small a equals to have taken distance between vertex and focus. In each of the six equations, we have taken a as the distance between vertex and focus. And number three, focus equals to midpoint of Latus rectum. These are the tools to solve the problems.